All right. Okay. Optimistic fool, so that means everything's going great. So here's the most important thing to get from that video. And to be honest, you don't even really need to get this piece I'm about to talk about. It's going to make part of what we need to do easier to remember. And I like to emphasize that it's a really unfortunate choice of words. But I think the video did a decent job of explaining, like I said, the negative numbers were seen as completely made up shit, right? Back when people could only think about real, physical, tangible objects. And now we have ideas that we could apply negatives to, right? So, one of the most basic ideas that makes this make a lot more sense is the fact that if I multiply by -1, I can look at that as if I'm turning 180 degrees. If I multiply 1 by -1, I turn a full 180. So it kind of makes sense. If I multiply by half a -1, I should just rotate by 90 degrees. So that's where the idea of lateral comes in. So to the side of the x-axis. This is not the y-axis. This is a different axis. So first of all, let me say this. Half a -1 multiplicatively would be this, which until this point we said is not real. The book calls it does not exist, which I don't like, because it does exist. It totally does. It's just not what we call a real number. Okay, I like it. You guys, some of you guys are like, why do I? What if I taught in my life that leads me to this? Come on, this is real shit. This isn't, I know it's got that terrible name, but it actually, I felt like it was Charles Barkley for terrible. This is what's known as the I-axis. We call this number I. The only reason we really do that is to actually make it easier to work with instead of having square root of -1 running around in our work. It's sort of like 3.141596, blah, blah, it never ends. We called it pi because it never frickin' ends. Let's just call it pi, and then I can use it. Same kind of idea. So this is the I-axis. So this would be, let me put this on here, this would be I, and this would be -I. So this is that lateral axis. This is actually the axis. Remember when he had the drawing like this? And then he lifted it up? You guys remember that from the video? If you didn't see it, you're like, oh no. But if you saw the video, he lifted it up a couple times. It was all colorful and shit, right? It's because this axis on that picture is coming out like this. It's lateral to the x-axis. This is the x, it's the y. So where is this axis? It's like that. So when you pick it up, you get those imaginary, horrible answers. There are answers to that equation he was looking at. They just happen to be on the side of the x-axis that we normally don't see. Because we want to, when we do x-y axis, we only do like one slice. And the thing that I never was taught, and I learned this a lot later, and some of the classes kind of danced around it, but nobody ever just told me the freaking y-axis is just to the side of the x-axis. Now, please don't give up. Please don't look away. Please don't. Everything I'm talking about is the idea. You will be able to do all the work even if you don't get this idea I'm talking about. But I do want to give you the full picture, just to put it out there. All right. I will, when we start doing stuff you need to be able to do, I'll say this is exactly what you will be able to do. All right? We haven't gotten there yet. This is one thing you need to know. That's the definition of I. That's what I is. That's what I do be. Okay, now, let's see what this kind of means. So if I take 1 times I end up at I. That's amazing. Right? So 1 times I is a 90-degree rotation. I end up right here. Now what if I multiply by another I? How far do I go from this? If I multiply I by I rotate by another 90. So what is I times I? negative 1. Now think about that. There's no real number that does that. We've talked about this directly. If I take a real number times itself, it always comes out positive. But why is that? Well, what was I? I is square root of negative 1. Get out of there. What's I squared going to be then? What do these do? So what's I squared? Yeah. Because of the way it's defined. But I was never shown this. I love how it makes physical sense. Instead of making a full turn, I make a half turn, and we just call that I. Because it's halfway to negative 1, and this is really weird. Doesn't mean it's not real. Unfortunately, we call it not real. It just means it's weird. We don't work with it a lot. If I take another turn, I end up at negative 1. And then if I take another turn, this makes sense in a few different ways. Visually, I'm at negative I. And sure enough, what is negative 1 times another turn? Negative I. And then if I take another term, I'm supposed to end up at 1. Well, what's negative I times another turn? That'll be negative I squared. What's I squared? Negative 1. So it's negative 1 times negative 1, which is positive 1. I end up where I'm supposed to. All right, so here's what you need to know. It's basically what I wrote up there, but I'm going to write it more concisely. You definitely need to know this basic definition. It's like knowing pi is about 3.14. So you've got to know I is the square root of negative 1. Okay, I like it. Are you... You're weird. Let's see if you work. I think you work anyway. Yeah. Here's what else you need to know. So what do you think I to the 0 power is? Let's just get that out of the way. What's anything to the 0 power? Okay, beautiful. So thank God this is still 1. What does that mean visually? I'm at 1 and I haven't turned at all yet. 0 turns. So of course I'm at 1 still. And that's a whole other way to think about what to the 0 power means. It's kind of cool. You haven't turned anywhere, so you're still at 1. I to the first is amazingly enough I. I squared is negative 1. And I cubed is negative I. So 1, and then I, and then negative 1, and then negative I, and then finally back to 1. So you can either just straight up memorize that shit, you can think about it this way, or you can think about it this way. You can build each step. Just keep multiplying by 1 more I and see where it ends up. Let me stop there for a minute. And I want you to realize something. What is negative 1 to the 0 power? Anything to the 0 power is 1. Okay. Anything to the 0 power is 1. Alright, I like it. What's negative 1 to the first power? Negative 1. What's negative 1 squared? What? Visually, go with me. Visually, what this is I'm not even considering the half turns. I haven't turned yet, so I'm still at 1. Then I make a full 180. Then I make another 180. Then I make another 180. Do you see how it keeps bouncing between 1 and negative 1? There's no other in between. This has 4 stops because now there's a place here and a place here and a place here and a place here. Right? So there's a beginning, there, and then back. But do you see why they're kind of related to each other? This is making a full 180, and that whole step process is making 90-degree turns. So it's going to pick up some more stuff. Stuff we didn't know existed before last time. Oh, I love it. You guys are all like, why? So now, no. This you have to, this piece, one way or another, you need to know this. And let me show you what this does for us. For example, this has only 2 possible outcomes. So can anybody tell me what negative 1 to the 237th power is without doing any work? Just using an idea. For every odd power, what's the outcome? Yeah, so it's -1 because it's an odd power, an odd number of negatives. There's going to be one guy left alive, right? So the Dothraki out, the lights go out. There's one guy somewhere. Ah, shit! Yes.
Can you repeat what you just said again?
Yes. So it's a couple things. You can notice the pattern. Every odd power leads to a negative number. More importantly than that is, of course, an odd number of negatives. If I have 3 negatives, 2 will kill each other, 1's left. If I have 4 negatives, no negatives left. That's why a negative to an odd power is negative, and negative to an even power is positive. There's only 2 options for that. That's easy as shit. There's 4 options there now. Right? So now, this is kind of cool. Stay with me. Is everybody semi-decent with this? On some degree, you're never going to be decent with that, and that actually is true about any person, right? There's some level of us that's like, what the shit? And unfortunately, it's just because of the way we decided to order how we teach stuff and the words that we use historically. We should just make a firm change and not call them real and imaginary anymore. Okay. This is free. Now, what can I do with this? Let me tell you this right now. The most important thing out of this is this one. I did not just say that you don't have to know all of them, did I? I said the most important one is that one because that's the one that happens the most. Okay? So now watch this. Can somebody figure out a way to see what this would be? Now let's piece it together.
Is it 11 or?
I to the 11th power, yeah. Sorry. Now you could just kind of keep going, over and over. Do you see how it starts over again? Where did I start? At 1. At the 4th one I start over again. So what's going to happen at the 8th one? It's going to be 1 again. Every 4, why does it make sense? Because every 4 turns I end up there again. Every 4 turns I end up there again. Why?
Because it's either the third.
Beautiful. Watch it.
You're going to end at the bottom.
Isn't this I to the 8th times I cubed? Every 4th one is going to be 1. Right? So this is I cubed, and that's one you're supposed to have memorized, -I. So the more direct way to do it, 4 goes into 11 twice with how many left? That tells you where you are in the pattern. If you divide it by 4 and see what remains, it's sort of like if I said to somebody, turn around 7.5 times. I'm like, no, I'm not. I'm just going to. So if I turn around 7.5 times, I can just do this and accomplish the same thing, right? So by killing every 4, I'm not rotating, I-11 means go around once and again and then 3/4 of the way. No, why would I do that shit? Let me take out all the 4s. Let me divide it by 4 and see what's left. And that's where I really end up. Let that make sense, even though I, square root, and negative, all this weird shit, but we just see a pattern. So like, what's I to the 46th power? 4 goes into 46. Doesn't even matter how many times. What's the remainder?
4.
What does 4 go into? 2? Yeah, 2's the remainder. Why? What does 4 go into? 44. So how many extra i's are there? 2. And what's I squared?
-1.
Yes. Cool.
That makes sense. So that's why we need to know that.
Yes.
Okay, 'cause it'll
So
make
that's
sense.
the way to figure out where you are in the pattern. And of course, you got to know what the frickin' pattern is, or you can't do shit with that knowledge, right? I like it. So this is important to know how this thing works. And it isn't a made-up thing. It's real. There's a whole thing about physics, electromagnetic waves. Well, oh God. But if I have an electric current running, there's the real part of something is the electrical part, and the imaginary part is the magnetic part. So they both have to be there. If I didn't have the imaginary part, I wouldn't be able to describe magnetic fields and shit. So there are physical things that depend on complex numbers to show up in my work. So if I didn't know they existed, I wouldn't have a way to get that and work with it and predict what was going to happen. If I put a magnet here, is what's going to happen. Okay. Now, I know our everyday life, we don't need to know that. But still, in general, somebody somewhere needs to know that shit. So it does have physical purpose. Okay, let's do another one. What about I to the 400 and, what do you got, Jeff? 17. I like seeing you guys like, really? What does 4 go into? That's near 417.
416?
416, right? 416. 4 goes into 416. So how many extra i's are there?
1. Sorry.
416 is 1. Done. See? There's 1 remainder, so that's the last I. So I to the 416 would be 416 rotations, and then 1 more. That's why I end up at I. Okay, I like it. There's a bigger thing about mathematics hidden in this, what we're doing. It's this idea of cyclic things. And that happens all the time. Look at the clock. It's cyclic. There's actually something called Z12, which is like how far up the numbers can go before they start over again. Well, it's related to Z12, in case any of my colleagues take issue. But that's way beyond what we want to talk about. But there's so many things that are cyclic in nature, and this is kind of getting us down the road of how do you handle something that's cyclic. There's got to be a quick way to do it because it keeps repeating its damn self. Right? So this is one baby example of how to deal with something that repeats itself. There's a nice quick way to figure out values. All right, I like it. Okay, now. So imaginary numbers, and again, that's just this crappy ass name, which I wish we would start calling lateral like the video says. But I will call them imaginary because the textbook calls it that, and everybody knows it as imaginary. But we know better. Right? They are the i's. So like 2i and 5i and all that stuff, those are imaginary. So a quick example by itself. Here, just remind me, what's the square root of 9? Beautiful. Now, we can do this now. What's the square root of negative 9? Let's break it up. That's the square root of 9 times the square root of negative 1. Is that cool? What's the square root of 9? What's the square root of negative 1? Done. So let that be quick now. What's the square root of 16? 4. So what's the square root of negative 16? 4i. The I just covers the negative part. I like it. What about this? Become a 3. What is 6i times 7i? Don't try to think. Yes, it is. But what's 6 times 7? I squared, right? And what's I squared?
1.
No. Negative 1. So this is negative 42. The opposite of the answer to life in the universe. I get. If you don't get that, it's an easy thing to work. Okay, now. There is a broader range of numbers that incorporates reals and lateral or imaginary numbers. And they are called the complex numbers, which that name sounds appropriate. They're complicated. They have multiple parts to them. So complex numbers look like this. This is what I was saying earlier about this would be the electric field and this would be the magnetic field. But don't worry, I'm sorry. I don't mean to make it sound like we've got to do physics. No, we're not. But there's a real part and an imaginary part. So every number we have ever worked with in our entire lives has been a complex number where b was 0. If b is 0, it's only a real part. That's why I call them the real numbers. The minute b is not 0, it's a complex number. For real, it's got the b part showing up. So for example, 7 minus 3i. That's a complex number. A is 7, b is negative 3. You stop there for a minute. So we've taken real numbers. What are real numbers? They are a complex number where b is 0. And now we realize there's a bigger circle outside of that that says, well, what if b isn't 0? Then there are just complex numbers. I like it. Maybe. Anyway, so I mean, anything you can imagine like this. So this would be a complex number, 2/5 plus 7/11 I. A is 2/5, B is 7/11. I like it. Some of you guys look angry. I'm sorry. You're like, what the shit? Okay, now watch. So, yes.
Are you supposed to solve it, or they're just...
No, they are, it's like, if I said, give me a real number. Give me a real number. 4, 3. Do you solve that? No, it's just an example of a real number. Those are examples of complex numbers. Now I'm going to do stuff like, well, what happens when you add two complex numbers, or subtract them, or multiply them, divide them? The minute we talk about some new kind of number, we have to investigate how the shit it works, right? So this is the part that's going to be very, very familiar. It's going to be almost too nice to believe, especially after this part. Now, here we go. What does your gut say? And this is a situation where you can actually listen to your gut. If you go into politics, don't do that kind of shit. What do you think? What does your gut say about this here? You can do it. Come on. Well, what do you do? You just
I'd like to.
well, add like terms. So what do you get? No, why is it not FOIL? Be careful. Because there's a plus sign. Don't be making problems worse than they are. We're going to do that in a bit. So what do you get? The real part is what? 10. Imaginary part is what?
Negative.
Negative. Oh, it's
5.
5i. Negative 2 plus 7. And then you're done. Do you guys understand? So there will be a series of problems that, and the only way to make this harder is something we know to be careful about already. What do you got to be careful about? That's done, right? That's done. What do you have to be careful about with this problem? Yeah, there's a negative in the middle. We know we got to be careful about that. We got to change both signs over there. So this will be 7 plus 5i minus 4 plus 2i. Is that cool? I mean, that's the same old shit. This is polynomials, really, where it's not an x, it's not a real variable, but it's still some piece we don't know. How you guys doing? Yes?
Does the, you know, it says 10 plus 5, does the I leave, like, there's no I?
It is there. That's an I.
I thought it
I'm
was-
sorry. It's not just a smudge.
Okay.
It's like, look at my tattoo. It's a smudge. No, that's an I. Yeah. I like it. Is everybody cool with that? You guys see what I'm saying? So this is exactly like 4 minus 2x and so forth. In fact, here, remind me of this. What is 4 minus 2 rad 7 plus 6 plus 7 rad 7? What's up? You all right? I hate it when I tell a joke. I didn't even know I did.
Just, yeah, 10,
10
5, right?
plus 5 rad 7. And what if I put a rad 3 here? Basically the same stupid thing, right? So what if I put a rad negative 1 here? Basically the same stupid thing, right? That's all it is. We already know how to handle this. It's just a radical. It happens to have a negative 1 inside, but it's going to act just like any other radical. And it's kind of better that we called it I, because now it's just a variable. It acts just like x did before. I just collect all my imaginary pieces, and I collect all my real pieces, and there you go. You can't put these together, of course, right? So what's this? This is going to be... Yeah, okay. I think you guys are just waiting for like the trick or something. There's no trick on this. Now when I multiply, there will be something extra that happens. Let's see if we get this. Here, you guys try to do this. Let me make you do it on your own on this really freaky shit. Ha ha ha. Sorry. I got too much enjoyment now. Do that. There's one thing I want to see who realizes it. Because I is not a variable, but it acts like a variable. The same way radicals act like variables, because there's shit we don't know, but I know what it is. I know there's one extra thing I can do on this. Now the first step. First step is the same as always. So what do you guys, what do I do here? What do I get? Plus what? Careful. 9i. Minus 10i. Minus, yeah, keep going. 15.
I squared.
Squared, yes. So one of the major problems is to get the square of that. I times I is I squared. We know that. I can immediately just directly do what? Immediately. Put the, yeah, put the like terms together. But I also know what I squared is. Right? What do I get in the middle? I get the negative I, right? The inward looking I. I don't know. Well, what is I squared? Let me stop there for a second. Right? It's sort of like if I have what's rad 7 times rad 7. What's rad 7 times rad 7? 7, right? So it's not, so what's x times x? X squared. I can't do shit with that. But if it's a radical of a number, I can do more with it. So I is a radical of a number. I squared is going to be that inside number, and that's negative 1. So that's why I said earlier, it's the most important one to know, because it's the one that happens the most. You get I squared a ton. So you just got to know it's negative 1. The big mistake I see students making is they replace all the i's with negative 1. That doesn't make any damn sense. Why would I call negative 1 I? There's nothing wrong with negative 1. It's square root of negative 1 that's freaky. That's what we call I. So here I get 6 minus I plus 15. So I get 21 minus I. Notice what form it's in. A plus BI. Your answer will always need to kind of be able to be put that way.
That's not negative I to the 0 power, is it?
Of course not.
Okay.
Because I had 9 i's and I took 10 i's away, so now I got negative I. I didn't have any I to the zeros. Well, I kind of did, but let's not go there. Huh?
It's like
I to the first.
base square root divided by first. But
Yep.
that's not anything that we,
That's just
Right.
square root of negative 1, which I don't want to put there.
right.
Yeah. But when I square it, now I want to put, now it's a nice real number. I definitely want to replace it with that. That's a lot better. Maybe? So the first step is just like back when we did polynomials. Foiling, it's fantastic. But I can do one more thing because I know what I squared is. That's why I can do one more thing. Okay.
You would want to get your answer back to like the original question.
How do you mean?
Or there's no way to get it back to like.
Oh, I see. Oh, thank God. You don't want to
Yeah,
try to break that up like that?
there's no way to.
Not really. We're about to get into a point. Well, we'll see. All right. But that would be unbelievably mean. Because there are a ton of things I could write down that would lead to that. So there's a lot of ways to factor it. We're not going to factor over the complex numbers.
Okay.
You're recruiting. You don't want to do that. So let me see. Let me do this first. This will help us out a lot. What did we do with this? What was it we had to do here?
You gotta make sure that the denominator doesn't equal 0.
No.
Oh, you would.
Sorry. Thanks for playing. My son is so disappointed. No. I can see that the bottom doesn't equal 0. There's no variables in there. there's numbers. I know they're not 0 because they're not the same.
Don't you want to get them?
But you want to multiply by the conjugate. Cool. Which is what?
2x plus 1.
Yeah.
Alright, I'm not going to do it. We've done this before. Blah, blah, blah. Right? Multiply, FOIL, blah, 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 blah. With me? Right? What if I would have had a rad 7 there? Would that really have fundamentally changed what I did? No. I would have just changed the plus with the rad 7 there. Who cares? So it doesn't matter what this number, what these numbers are. So what if they're -1? Well, I'll do the same. You guys semi with me? You guys okay with me not doing that? We've done that before. Right? Maybe. I'm not going to. So watch this. Now, how do I do this?
Add the 3 instead.
So multiply by what exactly?
The conjugate. Oh,
Yeah?
3i.
Almost? Yes. 2 plus 3i. What is I? It's a radical of something. So it's going to act like any other radical of something ever did. Finish that out. Go ahead. So you got to FOIL a couple times. Man, Jeff, you're really just asking for something. Brilliant. That's right. Let's see how I get 8 plus 12i plus 2i plus 3i squared all over. Alright. And I know what's going to happen on the bottom, but so I get 4 plus 6i minus 6i, so I'm not even going to write those. When I do this conjugate thing, the middle is always going to cancel. And then I get negative 9i squared. So let me see if we can do this. What is I squared? So this is negative 3. So I get 8 minus 3 is 5 plus 14i. This I squared again is still negative 1. So I get this is, well, maybe I should write this out, Jeff. Okay. Right? Because I squared is negative 1. So the bottom totally became real. Like totally. Became real. The imaginary part went away. That's what the conjugate does. Imagine what creative ass math people call this. This is the conjugate, so this is the complex conjugate. Way to go, guys. You're welcome. Otherwise. So it's a complex conjugate because it is a conjugate and it's got complex stuff in it. So we call it the complex conjugate. So on the bottom now I get 4 plus 9, 13. You can stop right there. You're good, but I just want to show you. I could break this up as 5 over 13 plus 14 over 13i. See, there's A, there's B. See that? Whenever you do something in complex numbers, the answer has to end up, or it has to be able to be put into form A plus BI. Funkadelic, yes. Some of you guys look worried, which is fine. It's the first time we're working with complex flipping numbers. I like it. All right, this is cool. I think that's all I give you so far.
What chapter is this one, teacher?
10-8. Student, let's see. Sorry. Yeah, there's one more thing I think. Yeah, there's one kind of little thing. I don't think I did this earlier. Let me see. No, I almost got to the point where Is your brain full today? I'm sorry. All right. Just gonna try to shove more stuff in there. If I say, what's the square root of negative, what do you got, Jim? 9 times the square root of negative 16. This is not equal to the square root of 144. That is not true. Because you're not doing the right order operations. What is the square root of negative 9? And what is the square root of negative 16? And what's 3i times 4i? And what's I squared? That's the right answer. So it's not positive 12, it's negative 12. Because what's the square root of negative to the square root of negative? Negative. Right? Jeff's been building it up to this point. Question. Square root of 11 to the square root of 11. 11. Square root of 5 to the square root of 5. 5. Square root of negative to the square root of negative. Negative. And the other shit's 144, so then it comes 12. So if you have the square root of a negative number, we normally immediately write that as something I. So how do I rewrite this? Here's something a little bit funkadelic. Square root of negative 11. What's a better way to write that? I don't know, man. But let's break it up. Square root of negative 1 times square root of 11. What's the square root of negative 1? I. Square root of 11. I don't freaking know. Alright. So the reason I don't put the I behind it is because if you do that, very often it looks like that's going to go over the I. Do you want to do the square root? Now imagine this for a second. The square root of I. Do you start to understand how that's really, really weird? No? You're not like, I barely get I, man. Why would square root of I be weird? Everything's flipping weird now. Anyway. So you don't normally put that after the square root symbol because it looks like it's inside them. So you just put it out front. So any radical that has a negative inside of it, you immediately take the negative out and write it as I. It just makes it easier to kind of look at and work with. Okay, I like it, maybe. Yes?
Can you repeat that last thing you said?
Whenever we have a square root of a negative number, we immediately take the negative out and write it as I. So if I have less aversion to having dots on the part. If I have square root of negative 13, what's that? Say it again. I square root of 13. Square root of negative 1 is I. That's why I'm allowed to do that. Square root of 13, I don't know. Now, if it's something I know, what's the square root of negative 25? 5i. All right. So that's the kind of stuff you need to be able to do with this I business. And it really isn't that huge. I know when I was talking about the concept, it was freaky as shit, and you're like, what do I even do with that turning around bullshit? But I just like to tell you that because that's the real story behind the scenes. What you have to nuts and bolts be able to do, like terms, I squared is negative 1. If it's a negative inside, you make it an I on the outside, that kind of stuff. Bam, bam, bam. Okay, maybe. So let me. All right, you ready? No, you're not. Can you factor this? The correct answer at the moment is no. But to be honest, that's sort of incorrect. We now know how to factor this. Before, we only knew real numbers. So this thing didn't work using only those numbers. Now, check it out for me. Multiply that out, make sure you get that. Take a minute, multiply that out, see if you get that. Some of you guys see why this works. I know some of you guys are like, in a math class with no pencil or paper, that's neat. How the shit do you get anything? All right. Well, if it works for you. All right, should be done now, right? X times x, x squared. Then you're going to get minus 5ix plus 5ix. Those go away, of course. And what's 5I times negative 5I? It's negative 25 I squared. I squared is negative 1. So I do get that. That is how you factor it. So x squared plus 49 is factored as x plus 7i, x minus 7i. I really don't know if anybody finds that neat or not. I don't know. To me, when I first learned that, I was like, that's kind of neat. I just couldn't do it before because I didn't know the right kind of numbers to use. Now we know the right kind of numbers to use. Kind of crazy. That's why I was always very careful when I started talking about stuff like it's not real, not it doesn't exist, it's just not real. We don't know it yet. Okay. So, that's 10.8. That's what 10.8 talks about. And this immediately flows into this. Let me show you this problem. Get out of there. By the way, before I go too far, on a test I could have a section where it says, simplify these radicals, don't use complex numbers. So like if you saw square root of negative 16, you would say not real. Right? I might do that, I might not, I don't know, we'll see. But in reality, if you wrote 4i, that's beautiful. Nothing wrong with that. What do you guys... So remember, what would I do to solve this problem? What would I do? Square both sides. Why? Because I have to get rid of that stupid square root, right? So then I would square both sides. All right, nothing big. This is recall, so this is old news. So this should not be as freaky as what we're doing now. Nice and straightforward and yay, right? And then you check it to make sure nothing freaky happens, and it works. Is that cool? That's a little, remember, we did this before. But now, the same idea of doing the opposite thing, of course, that's the whole idea of equation solving, is do the opposite. So, what would I do to solve this equation? And here's where things get a little bit different. If you just do this, and you get what? We know that's not right, or it's not complete. Because what else do I square to get 16? What else do I square to get 16? I can square 4 to get 16, or I can square negative 4 to get 16, right? And if I look at this as a little different way, now stay with me, I'm going to bring the complex numbers back in. I always love when students are like, there's no complex number in there. It's going to come, don't worry. The way we used to have to do this is I had to subtract the 16, and then I would factor this, and of course, how many parts do I get? What do I get?
2.
2 parts.
X equals 4 and 2.
Yeah, so x equals 4, negative 4. Right, is that cool? Right. So we know there's supposed to be 2 answers, and I think I said this, and so did the guy in the video. Fundamental theorem of algebra says there has to be 2 answers. If the degree is 2, there must be 2 answers. The degree is 7, there must be 7 answers. So forth. Stay with me now. All right, I like it. So what we need to get to the point of is this, and I'm gonna, every time we do a problem like this, I'm gonna repeat this and repeat this until you go even more insane than I've made you. When you write a square root down, when you write that down in an equation, you must put plus or minus down immediately to cover your ass for the 2 answers I know that exists. It's just a part of what we do. It's sort of a shortcut. Instead of sucking the 16 over and factoring the damn thing, this is a bit of a shortcut. You guys with me? So that's kind of like the give and take of the shortcut, is you got to remember to put that plus or minus down. All right, so now what if I had this? What is this? 2 there. X squared equals negative 49. Do what to both sides? Square root, the opposite of the square. The minute you write this down, plus or minus. Now for me, I know I've done a lot of flipping math. So when I write it, if I don't put the plus or minus, it physically hurts in a way. It's just like, oh, I gotta put down shit. But you're nowhere near that point. You gotta get used to that being just an automatic part of doing that.
Are you doing the plus or minus in both the equal sign or the
Say again, sorry? It's just on the square root. It's plus or minus this.
on the square?
Yeah. So I'll do this side. Oh, what do you get on? What is the square root of negative 49?
Plus or minus 7.
Yes. Please let that be not bad. Square root of 49 is 7. Square root of negative 49 is 7i. You know what the square root of negative is. It's I. So it's just going to come out like an I. Sounds painful. Maybe.
Is it when there's a negative you put an I?
When there's a square root of a negative, you put an I. I like it.
So if it was just regular 49, it would just be 7.
It would just be 7. Yeah. So I really, now see, so again, so what's the square root of 81? Square root of 81.
Plus or minus 9.
No, stop it. What's the square root of 81? 9. You guys, don't, I'm not trying to trick you.
Oh, it's not a square.
What's the square root of negative 81?
99.
9i. What's the square root of 100? 10. What's the square root of negative 100? 10i. I'm all excited. Right? You guys see it? Okay. So really, just to show you what's happening, I'm breaking this up as the square root of 100 times the square root of negative 1. That's exactly how that factors, right? That's 10, that's I. That's it, that's 9, that's I. That's why that's so quick. Those he should. So what about this one? All right, let's throw a little bit of a. This is not a huge deal. You say that, Jeff. What do you got? Yeah, and then I'm gonna. Yeah. Let's do this one, and then we'll do a little more interesting. More interesting. Shit. Don't overthink this one. That minus 4 bullshit doesn't matter at first, right? What do I have to kill right away? You don't FOIL this shit out. If you're doing that, stop. You don't need to. I'm sorry. I'm scared. Right? What would I do if it was just that? Square root. So I'm going to take a square root. I'm going to kill the square so I don't have to freaking FOIL. I don't want to do all that work. Since all the shit's collected under a square, I can just kill the square, and of course I immediately put. I like it. I'll do this side. Nobody's ever able to beat me tonight. And what do you get on the other side?
5.
Plus or minus. I like it. Keep going now. It's one more step. The only thing that doing more shit inside here does is it gives you one more last step. How do you get x by itself? Add 4. Now here's what you want to do. You want to put that out front. 4, give or take 5i. Complex them. I love it. So are these. Just less complex. They're missing the real part. And that's missing an imaginary part. This has got both a real and imaginary part. I like it. So not as painful as you might think something called imaginary or complex numbers would be. But still new. Right? We'll give you that. Okay. So here's kind of like the ultimate level of this, and then we got to level up past that. What if I add? What do you got, Jeff? Yeah, dude. Put it down there. I don't even know what to put down. Let's just do that. So let's do this one together. So first thing I do is square root. Good. Yeah, somebody knows to be ahead of that before I be all dorky. I'll be like, oh. So I'll do this side. Now what can you do on this side? Yes. And at the same time, what can you do with this piece? It's going to be written as what? I. And 20 is square root of 4 times the square root of 5. So it's the same old thing. If I have rad 20, you can break it down. There's a negative, just put that shit as I. Right? That's the new piece. And the 20 piece is old. We know how to do that. So I get x plus 1 equals plus or minus. Rad 4 is 2i, and then you have rad 5 just sitting there. Now, all the people that somehow jump this piece over here, I don't know how that magic happens. These are all connected by multiplication, so they have to stay connected. They're one little chunk. And then the last step is subtract 1, and I force it there in front, just so everything's kind of contained. And that is a funkadelic looking answer, but that's the answer. So I do want to, here's one more kind of level of this, of course. Just to remind you something. If I have this, hopefully it's kind of really obvious what to take care of first. So in general, how do I solve an equation? Wherever x is, whatever term or chunk x is in, get it by itself first. Sort of like the whole isolate the radical shit. Now this is kind of like the same idea. I'm isolating the squared part, because that's where my x is. So subtract 11, subtract 11. Unfortunately, you can't just stop here, like we could if it was a radical. Square root, I like it.